Welcome to Investigation 2.3, Minimum Measurement, Congruent Triangles number 2. This is our launch problem for this investigation. Our focus question: what is the smallest number of side and or angle measurements needed to conclude that two triangles are congruent? So in the last investigation we were looking at all of the angles and all of the side lengths and determining they're congruent based on all of that information. But I'm sure you notice after a while, this is getting really tedious, and I don't think I really need to do all of this work. Good. That means that you're actually seeing some patterns, even though you might not have seen the exact patterns quite yet. In this investigation, we are going to find the minimal number of measurements we may need to make to determine congruency on a triangle. So, in problem 2.2, you might have noticed that it's not necessarily to move one triangle onto another to determine whether two triangles are congruent. If you know that the corresponding sides and angles are equal, you can conclude that the triangles are congruent. For example, in triangles ABC and RPQ below, angle A is congruent to angle R, angle B is congruent to angle Q, angle C is congruent to angle P. So we can see that these triangles have the same angles. As well, side length AB is congruent to side length RQ, BC to QP, and CA to PR. Since all the corresponding parts are congruent, the two triangles are congruent. The triangles ABC and RPQ show a common way of marking congruent sides and angles as well. The sides with the same number of tick marks are congruent. The angles with the same number of arcs are congruent. So you'll notice that this ends up being a commonality in a lot of problems that you'll eventually see in geometry and then when you get into trigonometry as well. If you were to potentially have a triangle that had the same tick mark as perhaps a rectangle, you might be able to use that information to your advantage in the future if they're all in the same problem. So keep that in mind as you move on through time. In this problem, you will explore whether you need to know the measures of all the sides and angles of two triangles in order to determine congruence. So let's do just that. We're going to launch ourselves into problem A. All right, can you be sure that two triangles are congruent if you know only one pair of congruent corresponding sides? How about if you know one pair of congruent corresponding angles? Let's say perhaps we have this triangle and we can say that these two sides are congruent. Do we have enough information to prove that they are congruent? How about if we had these two triangles and we said these angles are congruent? Do we have enough information to prove that they're still congruent? Hopefully you're thinking in your head, well, what if I had a side length that was like this on this triangle? Or what if I had an angle like this on this triangle? Hopefully you're already thinking those things. If that were the case, we might still have the right angle for one of them or the right side length for something else, but we might not have enough to prove congruency. So let's check it out with some actual problems. So with the two sets of triangles that we just put up on that I just put up on the screen, the first one, we have one set of corresponding sides, and they're congruent. We have AB corresponds to DE, so side length AB corresponds to DE, and we can say there that AB is congruent to DE. We can say both of those side lengths are congruent. However, can we now say that the triangles are congruent because we have one side length that is? No. This triangle is clearly much larger, it's taller, and than the other triangle. They don't have the same area, they probably don't contain the same perimeter. They are definitely different triangles. As well, we can look at one triangle that has the same angle as another triangle, and once again, can we see that they're congruent? No. In fact, these two triangles look similar. They have the same angle measure for A and D, and they have the same angle measure for C and F, and the same angle measure for B and E. However, they're not congruent triangles. Interesting. Now, what if I had made this triangle like this? Still not congruent. What if I made this triangle way out here? Still not congruent. None of these triangles, even though they have one common angle at least, it's still not proving congruency. So, let's look at the next problem. Part B. Can you be sure that two triangles are congruent if you only know two pairs of congruent corresponding sides? How about two pairs of congruent corresponding angles? How about one pair of congruent corresponding sides and one pair of corresponding congruent angles? Looking at this, I'm already thinking of all these different situations. Maybe we have a triangle that looks like this and a triangle that looks like that. Ooh, that doesn't look like a triangle. They have two sets of congruent sides. Are they going to be the same? I don't know. How about if we have two sets of congruent corresponding angles? This angle is congruent to another angle here. Awesome. And this one is too. Is it going to be the same? Will we have the same stuff? Will we have two congruent triangles? And the last one, what if I have an angle and a side that is congruent? Do I have enough information to prove that those two triangles are congruent? Let's see some real life scenarios. Hopefully this number 2 is already screaming at you. Okay, so question number 1, we can look at this first one in the top left. Let's look at this first set of triangles. We have two pairs of congruent corresponding sides. One is AB and DE, and the other is BC and EF. These are congruent sides. However, do we have congruent angles? No, this angle is not equal to this angle. They are not congruent. This angle here is not congruent to this angle here. In fact, we're creating all sorts of messes on our drawing. So no, not congruent. Unfortunately, we need more information. Our next one, we have two sets, this one. We have two sets, in fact we have 3 sets of corresponding angles. 3, just like in the last problem. We have 3 sets of corresponding angles. Do we have a congruent triangle? Nope. Not here either. We clearly have similar triangles, but we do not have congruency. They are not the exact same. Every point A could potentially sit on point D. However, point C would not sit on point F. That would be impossible. Point C is going to sit right here. Point B also could not sit on point E if A was on top of D. It would be right there. We would not have the same triangles on top of each other. Not all the same line segments and not all the same angles would be exactly on top of each other with the congruency. Very last one. One set of corresponding angles and one set of corresponding sides. Is this enough to prove congruency? So here is our corresponding angle. B corresponds to E. Angle B corresponds to angle E. Or we could say angle B is congruent to angle E. As well, we can also say that AB corresponds to DE. And therefore AB is congruent to DE. However, are these triangles congruent? No. I know you can already see it, but no. Clearly BC and EF are not congruent sides at all. They're not congruent. Nope. So now my thought is, well, what if I knew, looking at just this scenario, what if I knew that this side was congruent to this side? What if CE was just that big? Because we have a congruent angle that is forced in there, and we have a congruent side. Could we prove that those two triangles are congruent? That is your job for the remainder of this investigation. I would like you to work through investigation 2.3, and you're going to do A through E. A nice giant hint is that we just did A and B, so you really only need to do C, D, and E for this investigation. But play around with the concept of congruency, and if you have any questions, make sure you ask. I will talk to you later.